Hello, before we get into the explanation, let me introduce my name. My name is Veneranda Baby Filatio. Special thanks to Miss Anna Fitriana SEMM as our lecturer for Mathematics, Economic and Businesses. This is our video explanation about maximum and minimum of function. So these are my partner. Rian Hidayat will explain first and second derivatives. Mary Andani will explain about function of two variable. Charlie will explain about example of those each first derivative, second derivative, and function of two variable. And lastly, I'm Veneranda. I will explain of those all 5 example questions.
The value of a function is said to be maximum if the value of the function is most great, whereas the value of the function is said to be minimum if the value of the function is the smallest in a closed interval. Please discount if f action c sama dengan 0, then fc is a stationary f on the x sama dengan c. Stationary value might only be a maximum reverse value, a minimum return value, or a horizontal lowering point on an f function graph. 1. f(x) has a maximum return value fc if f action x changes the sign from positive to negative on 0. 2. f(x) has a minimum return value fc if action x change the sign from negative to positive on 0. 3. f(x) has a horizontal lowering point on c if f action x does not change its mark as it goes toward 0. The geometry interpretation of this derivative test to determine what kind of extreme function can be viewed below. 1. f(x) has a maximum return of fc and extreme c fc. 2. f(x) has minimum return value fc and extreme c. 3. f(x) has horizontal lowering point on c with a growing point c fc. In this case, fc is not extreme value of function.
Alright, for the examples of maxima and minima for the first derivative, the question are: find the maxima and minima value of fx equals to 2x cubed plus 3x squared minus 12x. So we're going to search for the derivative of fx or f prime x, and it is 6x squared plus 6x minus 12. Because we bring down the power of number and then we times it with the variables, and then the upper power of number we minus it with 1. So 3 times 2 is 6, and then 3 minus 1 is 2. That gives us 6x with square plus 6x, because 2 times 3 is 6, and then 2 minus 1 is 1, and we don't write the power of number 1, so it's 6x. And since 12x have no power of number, it is actually 1, so when we times 1 to 12, it is still 12, and 1 minus 1 equals 0, so the x is gone. So the first derivative is 6x squared plus 6x minus 12. If fx and x equals to 0, then equals to 6x squared plus 6x minus 12. So what we're going to do is we're going to factorize it. So it gives us 6 times in x squared plus x minus 2, because 6 times x squared is 6x squared, and 6 times x, 6x. 6 times negative 2 is negative 12. So after that, we can do a little more factorizing in x squared plus x minus 2. So we're going to focus on the brackets, and this gives us x plus 2 and x minus 2. But when we put it equals to 0, it is x with negative 2 and x with 1. So remember, if bigger than 0 means minima, and if smaller than 0 means maxima. So fx equals 2x cubed plus 3x squared minus 12x. So we're going to input the x's in the x. So f negative 2 equals to 2 times negative 2 cubed plus 3 times negative 2 squared minus 12 times negative 2. It gives us negative 16 plus 12 plus 24. The total is 20. So it is bigger than 0. That means it is maxima, and this is the value, and f is 1. So 2 times 1 cubed plus 3 times 1 squared minus 12 times 1 is 2 times 3 minus 12. It is negative 7, and this means it is minima.
Derivative of the first derivative of a function called secondary derivative, which recommended d for dx in parentheses dy for dx equals d from 2 y for dx in power 2, or written y accent 2 d per dx in parentheses df in parentheses x for dx equals d in power 2 f in parentheses x for d x in power 2, or written f accent 2 in parentheses x. That means the second decrease is ordered d in power 2 y for dx in power 2, or y accent 2, or d2 d in power 2 f in parentheses x for dx in power 2, or f accent 2 in parentheses x. The second derivation of a function can be used to determine the subordinate of a function, and is usually used to determine the acceleration of a function of distance.
The example for second derivative for searching maxima and minima value is of fx equals to 2x cubed minus 3x squared minus 12x plus 7. So what we're going to do is we're going to find the derivative of the notation. So f prime x equals to 6x squared plus 6x minus 12, because 2x times 3 gets 6, and then 3 minus 1 equals 2, so it is 6x squared plus 6x, because 2 times 3 is 6, and then 2 minus 1 is 1, so we don't write the power of number 1, so it is 6x. And then 12x, there's only one power of number, so it is still 12. but for 7 is a constant number, so we don't write 7. It is equal to 0. So it is 6x squared plus 6x minus 12. So what we're going to do is we make fx equals to 0. So 0 equals to 6 times x squared plus x minus 2. And then we can factorize it more. It is 0 equals to x plus 2 and then x minus 1. And that gives us x equals to negative 2 and x equals to 1. So this is the first derivative, y'all. And what we're going to do is we're going to search for the second derivative. And because we already got the first derivative, we can use that to search for the second derivative. So 6x squared plus 6x minus 12 is the first derivative, and then the second derivative is 12x plus 6. And for the second derivative, we're going to input the number that is negative 2 in the earlier notation that we have got, that is 12x plus 6. So f double prime or double accent is negative 2 equals to 12 times negative 2 plus 6. That gives us negative 18. Now remember, if it's smaller than 0, that means it is maximum. So we're going to search if it is real. So we can input the negative 2 to the first notation, and that is 2x cubed minus 3x squared minus 12x plus 7. So it is 2 times negative 3 cubed minus 3 times negative 2 squared minus 12 times negative 2 plus 7. That gives us negative 14 plus 12 plus 24 plus 7. And the value of maximum is 27. And next, because we still have x equals to 1, so we're going to search if it's minimum. So f double x and 1 equals to 12x plus 6. So 12 times 1 plus 6, that is 18, because it is bigger than 0. It is a minimum. So let's search for the value of f equals 1. So it's 2 times 1 cubed minus 3 times 1 squared minus 12 times 1 plus 7. That gives us 2 plus 3 minus 12 plus 7 equals 0. So the value is 0. So we already got both of the value, that is 27 as maximum and then 0 as the minimum.
Hello everyone, my name is Mary Andani. I will explain about function of two independent variables. Okay, what is function of two independent variables? The function of the independent variables, or simply called the function of two variables, in the extension of the concept of a one variables function that has been studied in the previous modules. In a function on variables has the form y equal f open brackets x close brackets, with f 2 point r around r, namely the mapping from r to r. In this case, the variables x is the independent variables and y is the dependent variables. So the function maps as x value in the domain to 1y value in the codomain. For example, for y equal f open brackets x close brackets equal to x minus 1. If we take the value of x equal to, we get exactly one y value, namely y equal f open brackets 2 close brackets minus 1 equal 3. One x value can be interpreted as a value on the axis minus x, and their associated y value are presentation by a single point on the y minus axis. As the illustration can be seen from the following graphics image. In the figure, the function of one variable is explained, namely the mapping of the R2 of y equal 3, while the illustration of the function of two variables, namely f open brackets x y close brackets equal 2 minus x equal 2y, one pair of value open brackets x y close brackets equal open brackets 1 2 has exactly one pair z equal minus 3. In the function of two variables have from z equal f open brackets x y close brackets with f 2 point r2 minus r, namely the mapping from r2 to r. In this case, the variables x and y are independent variables, and x and z is the dependent variables. This function maps each pair of value open brackets x y close brackets in the domain to the place of one z value in the codomain. From example, from x equal f open brackets x y close brackets, if we take another pair open brackets x y close brackets. Okay, that's all from me. Explanation about function of two independent variables. To go deeper into the explanation that what I have explained, my friend will explain with an example problems. Thank you.
And for the example of maxima and minima, two independent variable, so the question is find the maxima and the minima value of fxy equals to x cubed plus 3xy plus y cubed. We have to find both derivative from partial ways, so we're going to focus first on fx, and if fx, we must focus on x, so every y means constant, and that when we derivative it means 0, so x cubed plus 3xy plus y cubed becomes 3x squared plus 3y, because we bring down the power of number 3 times with x, and then we minus the 3 with 1, it gives us 2, so it is 3x squared plus 3x y. So the x actually have a power of number 1, but it is unseen, so we times it with 3, and it left with nothing because 1 minus 1 is 0, so the x is gone, so it left us with 3y. And next we're going to search for the fy, so we're going to focus now on the y, so we consider x as a constant number and then they're gone. That means they are 0, so after that we get the answer 3x plus 3y squared, because x cubed means 0 and 3xy as earlier also the same, because they only have the power of number 1, so 3 times 1 from y, and then the y power of number 1 minus 1 equals 0, that leaves us with 3x, and then we plus y cubed, but the cube is from the power of number 3. We bring down, we times it with y, and then the 3 minus with 1, so 3y squared. And then we could subtract them by times them equally, so fx times with x, and then fy times with y. So 3x squared plus 3y equals to 0. We times with x, so it is 3x cubed plus 3xy, and then the fy we times with y, so it is 3xy plus 3y cubed equals to 0. And so because there is the same 3xy, we can remove them because we're subtracting them, and that leaves us to 3x cubed minus 3y cubed equals 0. Because it is the same, we can move the y to the 0, and then it gives us 3x cubed equals to 3y cubed, and we can simplify both of it, and we get x equals to y. So now remember, because x equals to y, we can pick one of the fx y. So I'm going to pick with the fx, that is 3x squared plus 3y. But because x equals to y, that means y equals to x. So we are going to change the y into x. That means 3x squared plus 3x equals to 0. And after that, we can factorize it again, and it gives us with 3x times x plus 1 equals to 0. And this gives us the first x equals to 0, and then the second x equals to negative 1. And because x equals to y, so there's the y is also, the first y is also 0, and the second y is also negative 1. So it is we're going to consider it as a coordinates, and we're going to write a coordinate, it is 0, 0, and then the b coordinate is negative 1, negative 1. So next we're going to find for the fxx, and we just times it, so it is 6x, and then for fyy it is 6y, but for the fxy it is 3. Okay, because we already get the number, we could continue the formula. So we're going to search for the d. So d equals to fxx times fyy minus fxy squared. So we already got the number earlier, so it is 6x times 6y equals to 36xy minus fxy equals to, it is 3, so it is 36xy times minus 9. And on the coordinate, on the first coordinate, that is a, x is 0 and y is 0, so we're going to input that in them, in the 36xy minus 9. So 36 times 0 equals 0, and there's left is negative 9. Because it is smaller than 0, and in the formula it is not extreme, because to be extreme, the dA or the dxy must be bigger than 0. And let's search for the b coordinates, that is negative 1 for x and negative 1 for y. So 36 times negative 1 times negative 1 minus 9 equals to 27. It is bigger than 0. So we can move to the next, we could pick fxx. So the earlier fxx is 6x, so we could input the x, that is 6 times negative 1 equals to negative 6. Because it is smaller than 0 in the formula, if the fxx is smaller than 0, it means it is maxima. And if it's bigger than 0, it means it is minima. So the value of the question that is x cubed plus 3xy plus y cubed equals to negative 1 cubed plus 3 times negative 1 times negative 1 plus negative 1 cubed. The total is 1. So this is the maxima value.
For my part, it's gonna be 5 example and its explanation of maximum and minimum function. For the first example, we have to determine whether it is maximum and minimum from its function. So for the first one, we have to find their f(x) accent, which it was the derivatives of fx, which it remains 12x power of 2 plus 12x minus 24. And don't forget the rules is fx accent equals to 0. So we can insert it into 12x power of 2 plus 12x minus 24 equals to 0. And then we can simplify it by dividing those with 12, which it remains x power of 2 plus x minus 2 equals to 0. Then that function we have to factorize it, with which it remains x plus 2 times x minus 1. That it remains x equals to minus 2. And for the last one is x equals to 1. Then next one, the fx accent equals to 24x plus 12. Where do we get those? It was the derivatives of fx accent. For the next one, we have to find those fx accent. It equals to 24x plus 12. Where do we get those? It was from the derivatives from fx accent. Then from the x that we find from the factorizing is minus 2 and 1. For the x equals to minus 2, we can enter it to the function of fx accent, which it was f minus 2 accent equals to 24 times minus 2 plus 12. Then it remains minus 36. Minus 36, it was smaller than 0. Then it means it goes to the maximum. So the maximum score for the fx is f minus 2. Then we use the function from the first one, which it was the fx one. Then it was 4 times minus 2 power of 3 plus 6 times minus 2 power of 2 plus 24 times minus 2 plus 2. Then it remains all of the maximum score is minus 38. For the second x that we find from the factorizing, it was 1. So f1 accent equals to 24 times 1 plus 12. It equals to 36, which it means more than 0, right? So that considered to the minimum. So the minimum score of fx is f1 equals to, do the same thing as before, 4 times 1 power of 3 plus 6 times 1 power of 2 plus 24 times 1 plus 2. Then it remains the minus score. Then it remains the minimum score is 36. For the second example, we have to determine those second derivatives of maximum and minimum from those functions. So the way how we do it is derivatives those fx that it remains the fx accent is 6x minus 5. Then we find the second derivatives, which it was fx accent, or we can say derivatives of fx accent, which it remains 6. So with the rule, it was fx accent equals to 0. So we enter those into 6x minus 5 equals to 0. Then 6x, the score of x equals to 5 minus 6. Then the x, it was remains 5 per 6. Then to try it out to the second derivatives, it was the fx accent, it was 6. So then we enter those x, which is f5 per 6 accent, it equals to 6. Then 6 is more than 0. Then it means it was the minimum score. So the minimum score of x, it was 5 per 6. For the third example, it was just the same, just like the second example. So we have to find those maximum or the minimum of those functions which from the second derivatives. So the way how we do it, it was the same. Find those first derivatives first of fx. It was minus 2x minus 2. Then the derivatives of those fx accent, it was minus 2. Just like the same rule of the stationary point, it was fx accent, it equals to 0. Then we enter those function, it was minus 2x minus 2, it equals to 0. Then the x remains minus 1. So we tried it out to the second derivatives of fx. So we enter those x into the fx accent or the second derivatives of fx, which it remains f minus 1 accent, it equals to minus 2. Minus 2, it was smaller than 0. Then it considered to the maximum. So the maximum point of those x, it was minus 1. For the fourth example, it was different from before. We have to find those fxy, or we can say it as the z. So from this case, the score of the x and y is 3 and 4. So for the x is 3, for the y is 4. So we entered those points into the fxy function. So 3 times 3 minus 4 minus 7, and it remains 2. So the score of 2, it was z. And in conclusion, the x1 is 3, y is 4, and the last one, z, is minus 2. For the last example, it was just the same like the fourth example. So we have to find those score of function g, which the point of x and y is minus 4 and 2. So we have to get those x and y into the function of gxy. So fxy equals to root of minus 4 power of 2 plus 2 power of 2, which it remains root of 20. From the square root of 20, we can get those value and simplify it into 2 root of 5. Then it considered to the g of xy or the z1. So we come to the end of our PPT and explanation about maximum and minimum function. Thank you and goodbye.